Now, part 3, electric circuit. What's the meaning of an electric circuit? And it's the title of our chapter. We have some electric components, like the dry cell. Here we have two dry cells, a lamp, and here the lamp is put in the socket. And in order to connect this lamp to the dry cell, we have to join them by something called connecting wires. This is the connecting wire. We can also add something called a switch. A switch can control the electricity, it's on off. So when we join these electric components together, we form something called an electric circuit. So as you can see that the switch, this is the switch, it's open. So when it's open, electricity cannot pass. The circuit is off, the electricity cannot pass. And the lamp in this case cannot glow. So this circuit is called an open circuit. While if we close it, then the electricity can pass and then the lamp glows. And the electricity moves from the positive pole of the dry cell to the negative pole. And that's the remark in this cloud. We will explain it later, but keep in mind that the electric current flows means moves, from the positive pole of the dry cell to the negative pole, from plus to minus. Now, if we want to represent a circuit, to draw a circuit, we draw it by symbols, okay? So here are the symbols of some electric components. We have to know how to draw these components using the symbols. So we have to study them. First, the dry cell, the battery. It has two poles, positive and negative. So we draw it by this form. We draw a line and it's positive, okay? Another line parallel to it and it's shorter. This is the negative pole and these are the wires. So this is a dry cell. We can rotate it. We can draw it like this way, negative and positive, okay? It doesn't matter. So, because the dry cell can be like this, plus, minus, and it also can be like this, plus and minus. So we draw it in this shape, plus and minus. It has two distinct poles. The positive pole is taller than the negative pole. We also have a lamp. Look at the symbol of the lamp. We draw it like this, circle, X, and from the middle we draw the wires. We also have a connecting wire. To join the dry cell to the lamp, we need a connecting wire. It's like a line, straight line. We have a motor. A motor is like a lamp. It needs electricity to function, but instead of glowing, the lamp glows. The lamp glows, but the motor rotates, okay, like a fan. So the motor has this symbol, circle, letter M inside it, and from the middle we draw the wires. We also have a switch. The switch can be open or closed. So the open switch, look how we can draw it. A line, we can put a point. Then we draw like a slide, and then we keep it open, and we draw another line here. So it's the open switch. And concerning the closed switch, it looks like the open switch. We can draw a slide here, but we close it. Or we can make it easier, because the closed switch, when it's closed, it acts like a connecting wire. It can allow the electricity to move. Then we can draw it like a connecting wire, but to differentiate it from the wire, we put 2 points, okay? So it has two symbols. We can use either one of them. So we have to study how to draw the symbols of these electric components. There are 6 symbols. the dry cell, lamp, connecting wire, motor, open switch, and closed switch. Now, a representation of a circuit by a diagram. Representation means drawing. A diagram يعني by using the symbols. Look at the figures. The first one, we have an open electric circuit. These are the dry cells in the battery holder. We have two dry cells. And this is the lamp in the socket. We connected them by connecting wires, this wire and this wire. And also we have this wire because we added also an open switch. So, dry cell, lamp, a switch, and they are joined by connecting wires. So we used here 3 connecting wires to join the components together. 1, 2, and 3 connecting wires. So this is an open electric circuit because as you can see the switch is open. So in order to represent it by a diagram, what do? We have to represent each component by its symbol. So the dry cell, we have to draw it by this symbol. The lamp, this lamp, we draw it by this symbol. And this switch, we draw it by which symbol? By this symbol because it's open, and we join them by connecting wires. So look at the diagram of the open electric circuit. Here's a dry cell, minus and plus. Here is the lamp, and here is the open switch, and they are connected by 1, 2, 3 connecting wires. And in this case, the lamp doesn't glow because the electricity cannot pass since the switch is open. Now, the second case in a closed electric circuit, now we close the switch. After closing the switch, look at the lamp, it glows. So the circuit becomes closed because the switch is closed. So we draw it like the first circuit, but instead of opening the switch, we close it. So the same, look. After drawing the first circuit, now the second one looks like it, but the switch in this case is now closed. After closing the switch, watch the lamp glows because the electric current moves from the positive pole of the dry cell. We draw arrows. The current, we draw it by arrows from plus to minus. Okay, so the electricity moves from plus to minus. So, a brief summary, in a closed circuit like this one, what happened in a closed circuit? In the closed circuit, the electric current I, we abbreviate the electric current by I because it's the intensity of the electric current, the quantity of electricity that passes through the component, and the lamp glows. So because the electricity moves, the lamp glows, we call it a closed circuit. While in an open circuit, like the first one, this is the open circuit because the switch is open, the electric current I does not pass, it cannot move in the circuit, and the lamp doesn't glow. So what's the meaning of electric current I? Electric current I am in this remark. It's the quantity of electricity that passes through the component. Okay, so how much electricity is moving in the lamp? And it flows from the positive pole to the negative pole of the dry cell. And finally, the last part in this chapter is part 4, conductors and insulators. These are objects. The conductors are objects like metals. They allow the electricity to move in the circuit, like iron, copper, gold, while the insulators, unlike conductors, are objects that do not allow the electricity or the electric current to pass through them, like plastic, wood, cotton, rubber, nylon, etc. And thank you. After explaining these ideas, we'll move to an experiment and then we will solve some applications.